So we've talked about gravitational potential. Let's now look at drawing equipotentials. And the first thing we need to say is what an equipotential is. So let's do that. I don't like this definition very much because it's kind of self-evident, but an equipotential is a line or a surface connecting points of equal potential. And you can see why I think that's stating the blindingly obvious, but that's what it is. So an equipotential is, in the simplest sense, a line which joins points of equal potential. It could, of course, be a two-dimensional shape joining points of equal potential, or it could be a three-dimensional shape, a sphere around this sphere, as we'll see. So that's what it is. Now, remembering that potential is defined as the work done per unit mass in bringing it from infinity to that point in the field against the field. If you have points of equal potential, then there is no work done in moving from one point to the next. So you can move around an equipotential and do no work. No energy is required. No energy is lost from that system, and no energy needs to be put into that system to maintain it. That's important, and you'll see why in a moment or two. So let's add in our first equipotential. So if you think about bringing an object from infinity to any point on this, its distance from the center of mass of this planet is the same, and so the potential at all of these points is the same. This is a sphere in 3 dimensions going around the planet. The second equipotential for equal changes, so going from the surface to here is a change of delta V, and going from here to here is a change of delta V. And our third equipotential for the same delta V, you can see the gaps here are getting bigger. So when you're asked to draw 3 equipotentials around a sphere, and whether this is a mass or a charge makes no difference to the shape of the diagram, showing equal changes of potential between them, as you're moving out here, you're going to see bigger steps. So the examiner will be looking for concentric circles. These 3 circles are all centered on the center of my charge or my mass here. And the distance between them is getting bigger. So in the case of gravitational potential, if this was the Earth, the gravitational potential on the surface of the Earth is minus 63 megajoules per kilogram. What that means is, if you want to give something enough kinetic energy so that it leaves the surface of the Earth and never comes back, you need to give it 63 megajoules of kinetic energy per kilogram. If you do the maths on that, that means it's leaving the surface of the Earth at 11 kilometers per second. That's escape velocity for the Earth. So I've gone minus 63 to minus 53, a change, a delta V of 10 megajoules per kilogram. And then I've gone to minus 43, another delta V of 10 megajoules per kilogram. And then minus 33, another delta V of 10 megajoules per kilogram. So it doesn't matter what the numbers are particularly. The minus 63 is a helpful thing to know. But my point is, my three equipotentials showing equal changes between them of, in this case, 10 megajoules per kilogram, are three concentric circles, that is to say, same center, centered on the center of the Earth, but the distance between the circles is getting bigger. So, surface of the Earth, minus 63, out 10 megajoules per kilogram to minus 53. This distance is greater so R2 is greater than R1, R3 greater than R2, so R3 greater than R2 greater than R1, but the changes are getting greater. So the change from R2 to R3 is greater than the change from R1 to R2.